Okay guys, this is our lesson for day 1 of our statistics chapter. We're going to be looking at mean and standard deviation notes. So we're trying to answer the question like, what does it mean to be normal? And usually when we're looking at normality, we want to say who's in the middle or what's just right, like what's not too hot or too cold, but what's right in the middle. So our measures of center are usually the mean, the median, and the mode. But the median means like perfectly the numerical middle number if you put them in order. Our mode is the number that occurs the most, and the mean is the one that's just the average. So when we go to interpret it, we're going to say like, what is the arithmetic average? And most of you have calculated averages before. We know that we're supposed to add them all together. So all the numbers in our list, we're going to add together. And then we go through and we divide by however many numbers there are. So our formula for mean, if you understand that we're just like adding up all of the numbers that we have collected and then dividing by how many numbers there are, that's fine. We also have this like more mathy way of writing it, which is using this little E symbol called sigma. Sigma is a Greek letter, and it just means the sum or the total. So if they're looking at like what's the total number for all of the x's or the sum of all the x's divided by that number. We're also going to ask you to interpret it, which means like put it into everyday language. So the average amount of whatever that x variable is what we're going to look at. And we're going to say that it's the average number or the middle number, the central number, whatever you call it. Okay. So you can measure lots of things for your x variable. This first set of data doesn't really have anything that they show that you measured. But the first one, if you want to look at its mean, like what number's exactly in the middle, there's your average. The average of the first data set is 6. And if you look at the second data set, like it's also very symmetrical. It also has a middle x number of 6. So both of these data sets have the same mean, but they don't look the same. I mean, they have the same overall shape, but they don't have the same spread. So spread means how clustered together the data is. So on the top, we see data that's very close to that mean. So its standard deviation or its spread is very small. Whereas in the other one where it's much wider overall, like it's a little bit of a fatter distribution, it's thick. So it goes a little bit more spaced out. The way that we're talking about that spread then is called its standard deviation. So the symbol for that is this little s sub x. So the standard deviation is going to tell us the average distance of our observed data or what we're seeing in our x variable and how far it is from the mean. Since distances have to be positive, you'll look at the formula and kind of freak out just a little bit, but it's not that complicated. They're going to square them so that they become positive, and then they're going to take the square root, which is essentially going to give you the absolute value, like the absolute overall average distance. And we see that little guy sigma again, so we're going to have to find the total of something before we divide it and then square root. Our standard deviation interpretation, like we have the formula there for you, and then its interpretation, we'll do that on the back, is the average or on average how far that x variable differs from the mean. So we're going to talk about how much it varies from our x bar. And we'll say it varies by about however much we calculate our standard deviation to be. Okay, so two formulas, one for standard deviation and one for mean. All right, in this first example, we're just going to go through and like how do we use those definitions to talk about normal or unusual data sets. So first thing we're looking at is, it says the mean birth weight of infants born at a certain hospital in the month of April was 128 ounces with a standard deviation of 10.2 ounces. Okay. So the thing that we're measuring, or our x variable, is the birth weight of the infants. So we can see on our x-axis here, that's how they've labeled it, weights of infants. The number in the middle of this chart is the mean. So there's your X bar. And then the way that they've counted is they're counting by those standard deviations. So if you count and add 128 plus 100 or plus 10.2, that's how they're getting that 138.2. If they add 10.2 to that, that's where they're getting our 148.4 plus 1002, and you get the last number. So these are 3 standard deviations above the mean. That's 1 standard deviation, 2 standard deviations, and 3 standard deviations higher than our average. If we go the other direction and we subtract 128 minus 10.2, that's going to be minus 10.2 minus 10.2. So they're just counting by this like spacing. So that's what standard deviation is telling us. It's telling us like how spaced out or spread out our data is. If we're supposed to interpret it, we're going to follow that script, and this one's already like partially filled in for you. So on average, the weights of infants, that's our X variable, differs from the mean weight, of 128 ounces by about 10.2 ounces. Okay, so follow that script until you get more comfortable with explaining what standard deviation or what mean is. And then these questions are just going to ask you about basically, if you're above average or below average. So it says if an infant weighs 117.8 ounces at birth, does she weigh more or less than normal? And if you've already gone through and scaled that axis like we asked you to do on the homework, you'll see like, oh, it's below. Like obviously, if that's the average, 117.8 is smaller than the average. So she is less than what's normal. All right, and then they say how many standard deviations from the mean is that number? Well, since it's only one space behind it, we would say that that's 1 standard deviation. Below the mean. So mathematically, a lot of times we might even see that as like X bar, which is our mean, minus 1 standard deviation. She's 1 standard deviation below. That's why it's negative. Okay, the next is going to give us 2 different children. One is Jackson, and Jackson weighs 2 standard deviations above the mean. So if we look for Jackson, you go to the mean, he's 2 standard deviations above it. So Jackson is right there at 148.4 ounces. And then they talk about Ava. It says Ava weighs 1 standard deviation above. So 1 above, here's where Ava's at. And then we're just supposed to compare them. Which child is considered more normal? Well, whoever's closer to the average is more normal. So in this case, it's Ava. So Ava's weight is more normal. And that's just because she's closer to the mean. Okay, and then it says which infant is heavier? Well, you can see like Jackson weighs more, so that one's just going to be. Our last question is about Emma and David. So we have 2 more kids. It says Emma weighs 107.6 ounces at birth. So if we find her on our scale, there she is. She's below average. And David weighs 138.2 ounces at birth. So he weighs the same amount as our Ava. Which child has a more unusual weight? Well, if we go and compare, Emma is 2 standard deviations below and David is 1 standard deviation above. So in this case, Emma is more unusual because she's further away than David is. And so we would say Emma's weight is more unusual. Because it's further from the mean. right, for example 2, we're looking at calculating or computing the mean and standard deviation from a data set. And we're going to be needing those formulas again. So our formula for mean should be the sum of all the x's divided by n. And our formula for standard deviation is going to be, we're going to find the sum of all the x's minus the mean and then square those. Divide by n minus 1. And then at the very end, take the square root of that. So on the back side, you've looked at a random sample of 8 students and you've asked them how many hours they've spent on homework each night. So that's your x variable. We have their responses that are listed in a data set, so they just have it listed. And then they also have it graphed over to the side in a dot plot. And so you should be able to read each one given to you. So we have, you know, like 1 showed up 1 time, 2 showed up 3 times, 3 shows up once, 4 shows up once, 5 hours shows up twice. Overachievers. All right, so first we're going to calculate the mean, and so we need to add all of those numbers together. That's what it says for the sum of our x's. So we need to find the total of this row. So 1 plus 2 plus 2 plus 2 plus 3 plus 4 plus 5 plus 5, and then we're dividing by the sample size, which was 8 students. If you add all of those together, you should get 24. 24 divided by 8 is just 3. So now we know that the mean amount of time that people spend on their homework is 3 hours. And then we also want to go through and then interpret that. So if you look on the front again, you have those scripts. Like we're learning that the mean is 3. So what that's telling us is that on average, and then we'd want to say our little X bar, the amount of time spent on homework is 3 hours. Oops. All right, so now we're gonna find the rest of our calculation for standard deviation. First, we wanna know how far does it differ or deviate from the mean. So for all of these problems, it says start with x, 2, 2, 3, 4, 5, 5, and then subtract off that average that you just calculated. So before we can do this column here, you have to know the mean because that's what it's asking you to do. Subtract 3 from each of those numbers. And so with each one of them, like you'll either get a positive or a negative number depending on if it's below average or above average. So the kid who spends 1 hour on their homework spends 2 hours less than what's normal. The kid who spends 2 hours on their homework spends 1 less hour on their homework than normal. The kid who spends exactly 3 hours doing their homework, they're perfectly normal, so they're at 0. 1 hour more than normal and 2 hour more than normal is kind of like those deviations. Then we want to take those values and square them. So if you square those differences that you just found in the last column, you get 4, 1, 1, 1, 0, 1, 4, and 4. Okay. And now down here at the bottom, there's more space for us to do work. We're going to find the total of that column. 4 plus 1 plus 1 plus 1 plus 0 plus 1 plus 4 plus 4. If you add up all of those, that's what the sigma is asking you to do. You'd get 16. Okay, so that's the total here, and that's just part of our formula. So if we look at that standard deviation formula, that total from that row is the sum of the differences of those squares. Okay, so we're going to take 16, and the next part of the formula says divide it by n minus 1. Well, we had 8 people in our sample, so 8 minus 1 is going to be 16 divided by 7. And then you want to take the square root of that. make sure you're using parentheses or you hit enter when you're using your calculator. So you would do 16 divided by 7, and then you can do square root of that answer. And so we get 1.51 for that entire standard deviation. Okay. And so if we're going to interpret that one, we would say something like on average, the number of hours spent on homework differs, so it's like it's different from 3 hours, which was our mean, by about 1.51 hours. I guess that should be plural too. All right, so try your best to stick to those scripts. You can probably say from the mean of 3 hours by about 1.5 hours. That's just telling you how spread out the data is. Okay. We're going to try it again with another sample set. So in this one, you're looking at quiz scores. So first you would just like list what the quiz scores were: 67, 71, 72, 86, and 96. Then we want to calculate that average. So we would go through and we're going to add together 61 plus 71 plus 72 plus 86 plus 96. That's your total. So 392 divided by, you had 5 total test scores. So when we divide that by 5, you get 78.4 as your mean. Okay. So now each one of these numbers is going to be subtracted, or you're going to subtract from them that that 784. So if you go through again, 67, 71, 72, 86, 96, and we subtract off our mean, which was 78.4. In your calculator, like typically you're just going to do like 67 minus 78.4, and then you're supposed to square that number. So it'll come out like the square of that. So you'd get, like negative 11.4, and then you're going to square it, which is 129.96. Okay, so if you subtract and square, you get negative 7.4, and square that. 54.76, negative 6.4 squared is 40.96. 7.6 squared would be 57.76, and then 17.6 squared is 309.76. Okay. Then we're going to find the sum or the total of that last list. Okay. So that total comes out to be 593.2. So we just took those squares and we found the sum. And then in our formula, we're supposed to take that number, divide it by n minus 1. So 5 take away 1, we're going to divide it by 4. And then we're going to take the square root. So divide by 4. The square root of that answer, which was 148.3, should give us about 12.2. So if I'm asking you to interpret that, What it means is like the average that people get on the test is a 78.4, but we see a lot of variation. We see about a 10% difference between those scores. It's kind of a lot. All right, last 4 days, because you're gonna, what else are you gonna do during your little homestay? This kid's gonna catch Pokemon. Josh, I don't know if kids still do this. Josh is gonna catch 10 Pokemon, 50 Pokemon, 10, 10, 10, and 50. So our first step is find that average. We're gonna add up all those numbers. 10 plus 10 plus 10 plus 50 should be 80. 80 divided by 4 days, he's catching 20 Pokemon on average. So if we do 10 minus 20, that would be negative 10. Negative 10 squared would be 100. Again and again. 50 minus 20 would be 30. So there's your above average day. 30 squared is 900. Okay. Then we want to add up all of those numbers. 300 plus 900 is 1200. So the sum total of all of those square differences is 1200. And then we want our formula to be that number divided by n minus 1 square rooted. So 1200 divided by 3 is the square root of 400. This one's a little bit strange because the standard deviation is also 20. Pokemon. Catching them all. So you have, on average, 20 Pokemon that are being caught, and then also quite a bit of spread. The variation is also going to be 20 Pokemon. Okay. So your homework for this night is then your day 1 homework from the packet. And that looks like a buff colored worksheet. Looks like that. Okay. Good luck, guys.